Okay, the reaction rate is depends on the concentration, temperature, catalyst. Okay, means that the higher concentrations, the more probability of the molecule to collide. So means that it will increase the reaction rate. Okay, when we increase the temperature, the rate of the reaction also will be increased because they have more possibility to react which is other. However, not of the collision will produce or will lead to the reactions. And the effect of catalyst will reduce or lowering the activation energy means that it will increase the rate of the reaction. Okay, the rate of the reaction is proportional to the number of molecule collision per second or the frequency of the molecule collisions. Means that the higher the molecule will have a probability of molecule to collide which is other, and means that the frequency of the collision will be increased. So the rate of the reaction will also increase. Okay, this relationship explains the dependency of the reaction rates on the concentration or the number of the molecule present in the system. Okay, for example, when we have a reaction between a reactant A and B to produce a activated complex, okay, which is the reaction between molecule A and molecule B, will form some products directly. Okay, which is when we double the concentration of A, means that the molecule will collide each other frequently. Okay, and because they will be twice as a number of molecule of A increase. So the rate of reaction is also increased by a factor of 2. Okay, similarly, when we double up the concentration of B, means that the rate of reaction is also will increase by 2. Okay, what is the relation between the activation energy, temperature, and the rate constant? Okay, as mentioned before that the reaction only occur when the collision occur between the molecule with the correct orientation and with the enough kinetic energy. So when we increase the temperature means that the molecule will move faster and they have a greater kinetic energy. So when molecule is collide, part of the kinetic energy will convert into the vibration energy, which is vibration energy is energy which need to break the chemical bond and to produce products. However, some of the which is in the minimum collision energy below, which is below the EA, which is there is no reaction occur. Okay, what is mean by activation energy? Okay, activation energy or EA is a minimum amount of energy required to initiate a chemical reactions. Okay, to ensure that the reaction taking place means that from reactant to produce a product, the reactant or molecule should be collide and with enough energy which is should be equal or at least equal or greater than EA activation energy. So during the collide, the molecule will form the activated complex or transition state, which is the temporary species before we can form a products. And you should note that not all reactant will produce a product because only molecule will have enough kinetic energy will produce a products. So we can relate this speed or rate of reactions with the Maxwell Boltzmann distribution. Okay, figure A and B, you can see the potential energy of exothermic and endothermic reactions, which is the reaction can only occur when the energy is higher than the activation energy. So for exothermic reactions, the product is more stable than the reactant, while for endothermic, the reactant is more stable than the product. Okay, Arrhenius equation shows the relationship between the rate constant K with respect to the temperature, which is the rate constant is proportional to the A or collision frequency. So means that rate constant will decrease with increasing the activation energy and increasing the temperatures. So this is the relationship between the rate constant and collision frequency, which is EA is the activation energy in kJ per mole, and R in this case we use 8.314 J per K mole, and T in Kelvin unit, and A is the frequency factor or collision frequency. So from the Arrhenius equation, we can plot the graph which is from ln K is equal to ln AE minus EA per RT. Then we rearrange again these equations. So ln K is equal to ln A minus EA over RT. So when we plot the graph, ln K versus 1 over T, so we can get the straight line, which is y is equal to mx plus c. So the slope is equal to EA over R. Okay, what is the means by reaction mechanism? Okay, reaction mechanism is step-by-step sequence of elementary reactions by which overall chemical change occur. Okay, mostly chemical reaction involve stepwise, which means that they take more than one elementary step to complete the reaction. For example, you can see here that the formations of the nitrogen dioxide involve several elementary steps. Firstly, nitrogen oxide will react with nitrogen oxide to produce a dinitrogen dioxide, and then the intermediate of dinitrogen dioxide react with oxygen to produce a nitrogen dioxide. So you can see here the formation of nitrogen dioxide will produce a reaction intermediate. Okay, reaction intermediate is the molecular entity that is formed from the reactant, from the reaction between the reactant, and react for further to give a directly observed product of the chemical reaction, which is the final product is nitrogen dioxide. Okay, the species that appear in the chemical mechanism is called as intermediates. So in the reactions, the intermediate is nitrogen dioxide, which is considered as a bimolecular reactions, which is it is involved two species here. That's why it is called as a bimolecular reactions. When the elementary step only involve one molecule, it is called as unimolecular reactions, while when elementary step involve three molecules, it is called as a third molecular reaction.